Okay. What's up, folks? Welcome to MicroCinema 4K, the highest quality live stream microscopy in the world. I'm Jason, and if you're watching, you are part of a movement called Diet Toms. So thanks for showing up. We got a lot of really cool stuff today. We got some first time organisms for the stream. It's going to be really cool. Yeah, and then we've also got a very cool slide. So we'll talk about this too. So let's see. What did I do today? I went out to Scotts Valley, which is sort of in the Santa Cruz Mountains. And there are a couple of ponds there that I frequent. They're kind of in my rotation. And I got 2 jars. I got 2 small little jars, mason jars of water from 2 different ponds. But I don't know, what's really cool about these ponds is that they really seem to just like every time, I go there every month or so, and like there's always something cool, there's something different going on. So one of the things I really recommend if you're doing microscopy and you're getting like pond water organisms and whatnot, is like, don't assume that, just because you got a sample at one spot, that every time you go back, you're going to get similar stuff. In fact, a lot of times, these micro environments are very dynamic, and so you'll see stuff come and go, and you can always be surprised, even just with the local pond. Okay, and we're doing a whole lot of stuff today. So let's just jump into it. This could be a long stream, so I hope you all are ready for that. Let's start off by talking about this slide here. Okay, yes, and my microphone's still working. That's great. So what the heck are these things? So all of these things are sponge spicules. And spicules are basically the structural components of sponges, like marine sponges. And they are just really fabulous. There is a ton of diversity of form. I really particularly enjoy this one here. Also, something weird is going on with my camera today. I don't know what it is, but I'm shooting at even lower ISOs than I normally do. So I don't know. We'll figure that out. That usually just means I've forgotten to set something properly. But you know what? Maybe I did kind of fiddle around with my lamp too, so maybe that could be it. Yeah, just check these things out. This one's so cool. I feel like it's maybe this is a part of like this one here, and these little like tubes that are crossing here. These look like little like micro channels or something like that. Maybe that has to do with sponge filtration stuff. And then these like crazy barbed ones here too. And so basically sponges are like, so these things are siliceous. They're like glass basically, kind of like diatom frustules. And then the sponges are sort of built out of these and like some gooey stuff. So it's just a bunch of these things all clustered together. And these are just, it's absolutely such a fabulous slide with all these incredible sponge spicules. Here's a kind that's like got it's almost like a little like dandelion or something. You can see there's a little indentation there, and that's That's I was looking at some literature, and that is a normal thing. Go back to the NX here. How am I getting such high exposure? That's ridiculous. I don't know. It's so weird. And yeah. So I don't know. This is a slide we might have to come back to sometime after I've studied more about sponge spicules and can talk about them. But we can enjoy it in all of its glory. I wonder, maybe I have the wrong, or do I have two filters on? I wonder if that's the case. Am I supposed to use this one? No, it's definitely not that one. I don't know. Something weird's going on. I wonder if, maybe that's it. Crazy. Anyway, enjoy the craziness, the psychedelic colors. All right, see you, Teeny. And so in preparation for our first couple of live slides here, I'm gonna switch to a low magnification condenser. You know what? Actually, I'll go ahead. Yeah, I'll switch to the dark field. I think we'll just jump right into the dark field. And here we are with the 4X. And what you can see, maybe you didn't notice it before, is that this isn't just a bunch of spicules that are randomly strewn onto the slide, but this is actually a slide which is also a beautiful, carefully crafted piece of art. Someone painstakingly went through and arranged all these sponge spicules, and it's pretty awesome. I'm gonna turn down the music just a little bit there. Man, what an incredible slide. I'm so happy I got this one. I can't believe I think I got this for way less than it's worth. So that's cool too. Okay, so let's go ahead and jump in. Oh, I'm actually gonna not only am I gonna switch to that, but we'll see. This could get weird. Yeah, that's what I wanted to do. That's why I wanted to use that one. So give me a second here. I'm going to switch into the slide, their first slide. And this is an extra thick preparation here. And we got some interesting little critters on it. Let's see. Okay, so I want this one in like that. There we go. And then I want this turret. Boom. In like that. Okay. And here we go. Wow, this is actually so bright that I need to put another ND filter on here. And there we go. So right now we're actually using a lens that we have not used on the channel before. And that is a 1x lens. So, so this image here, well, I guess it's actually then, since my projective eyepiece is 1.67x, but it's yeah, this is a pretty low magnification. This is almost like using a macro lens. And this little crazy critter here, these guys, I believe, I'm like pretty confident that these are leeches. And I don't think they're the kind that necessarily suck your blood. This up. But they are leeches. And one of the things that was really interesting when I was getting these guys up is that they are they're very, very sticky. They're very capable of adhering to the cover glass. And so even when I was like, I had him under the stereoscope and I was trying to pipette him up, I was trying to, like, you know, use the suction to really suck him up into the pipette, or like sometimes I was like blowing with the pipette to like try and dislodge them. And it took me like probably 10 minutes straight to get these leeches, to get one leech onto the slide. But they are pretty cool. I think so anyway. That's so weird. I don't know what's going on with my camera. I'm not necessarily complaining because I'm getting way more light, but there's something strange. Something I did fiddle around with my my OBS settings. I might have done something dumb. Yeah, what's with all the black spots? Nick asks. I don't know. I have no idea. Some kind of leech stuff that I'm not overly familiar with. There we go. Now I've got the condenser set up a little bit more properly now. They are super neat though. Look at this thing. Okay, let's go ahead. We'll switch to a dark field condenser. I think this one should be able to light them up. Yeah. There we go. And so kind of over here, this is a little leaf of duckweed here. And so this is like a couple millimeters long. So you can get a sense of like the scale of these leeches. They're pretty large, like, you know, as far as the stuff. This is like an extra deep well, kind of don't normally use. that thing. And so yeah, oh, and see, this is how they move. They kind of inchworm around, so they have, and this is at least how I have learned to discern leeches from other worms. Is that the leeches, they will always like stick on with their butt, and then when they move around, they'll grab with their head, and then move their butt, and then re-suction with the butt. Yeah, these things both have two little eye spots. This one's on the move now. Poking around. It's nice to see. Oh, we have a this is a ciliate here. This is Frontonia. Is that cool? A little ciliate that I didn't necessarily intend to get on the slide, but here it is. Oh, look at this. Oh, wow. I didn't know that could happen. Look at this. There are little epibiont ciliates attached to this leech. I thought they only like stuck on little crustaceans, but apparently that's not the case. Wow. So let's see if I do the 2x. Okay, it looks like that. Yeah. Kind of cool, but got that like the vignette can kind of look neat sometimes. I feel like. Wow, look at I love how the leech is like lensing the light there when it was over the duckweed. What's up, Val? Good to see ya. And you got little crustacean exoskeleton there. Yeah, so we got some leeches. Pretty neat. And then we've got on this slide. So this is from these leeches came from a pond called Quail Hollow Ranch, or I guess a park called Quail Hollow Ranch, and there's a little pond there. And but then I went to another place and collected some stuff as well. This is a different pond, and we've got a bunch of cool stuff here too. Let's see. Oh yeah, we'll try the 2x. I wonder. Oh, I think I can move this down a little bit there, and then boost the exposure up. Yeah. There we go. Now we get kind of a more useful view. So we've got some worms. Let's see, the size of the leeches was, I'd say the leeches are a good 4 millimeters rather long. But of course, obviously, you know, they don't stay one length necessarily. Wow, check out this super dark worm. Whoa. Got eyes. A couple eye spots. This one, I remember when I pipetted it up, I remember thinking it looked a lot like the Typhloplana, just because it has some sort of like torpedo shape to it and the way it swims. Go to the 10x here. If you notice some chromatic color fringing, that's because I've got my low mag lens turret on. So my 10x right now that I'm using is actually an achromat 10x. So it's got a little bit of color fringing, but I don't think it detracts too much. Yeah, this thing's so cool. It's funny, some people do react kind of negatively to worms. I can definitely understand leeches. I mean, you know, just the word leech is, you know, can unnerve people. Got a nice little, these are some really cool. So this pond in particular has whatever species of ostracod this is with the little green splotches. And there's a lot of them, and they're all swimming around in there, and they're like very distinct. This is a nice stenostomum here. Look at that beautiful Spirogyra. And we've got other slides that will be featuring. Oh, this worm's not doing so hot. Got other slides that will be featuring more samples from these places. Ooh, is this a big testate amoeba? What is that? I don't know if it's a testate amoeba. It doesn't have any, like, the heck is that thing? It'll be bright. It's something. I don't know. An egg, perhaps? It doesn't seem, I don't know. Doesn't seem to be doing too much. Let's go ahead and do a little bit of polarized light. You know, while we're here, never a bad call. Throw a little polarized light into the mix. Go. Wow. Whoa, dude, check out. Whoa. Wait. Look at that. Look at there's like something like the eyes. The eyes are glowing. But then there's like stuff around the eyes too. It's very distinctly glowing. And I'm wondering, am I like looking at, are those like specific cells that are associated with, those brain cells or something the eyes are connected to? Thomas is asking if I've messed around with autofluorescence much. So I have, but not on stream before, and that's mainly because it's just like, it's difficult to set up my fluorescence stuff, you know, and maintain like access to my other techniques, since I gotta like put a different attachment on. But it's definitely something we will do sometime. It's just like when I have like, you know, when I'm prepared for it and I have a specimen that I think is really good for it, we will do it. Ostracod, super bright, as always. So here's that one darker, like Typhoplano one. And this one, see, the eyes don't really light up. A little paramecium there. Yeah, a couple more worms. I think there's a Hydra on here too, somewhere. I think that was on here. Wow, this one's so cool. This one's like very distinct. This is got a weird, very distinct polarization response. I thought there was a Hydra on here anyway. Yeah, I'm misremembering. Oh, yeah, and then this thing too. Yeah, what was this? What's going on with this thing? Do you have any polarization secrets, you little orb? The answer seems to be no. Seems to be very standard. Okay. Oh, let's go check out the leeches while we're here. Oh no! What? Oh, they have a huge polarization response. Whoa! No way! Look at that. Oh. Dang. Am I becoming a little leech boy here? And what's about to happen? Wow. Dude, no, look at them. When they stretch out. Oh no. Oh, this is so polarization interesting. When they stretch out, they're becoming, oh, look at that. Oh, guys. Guys, this is actual like polarized light microscopy that's happening right now. We're learning about these things. Wow. So the reason I'm so excited is that like the polarization is they're becoming like more optically active when they stretch out, which actually makes a lot of sense. Yeah, look at that. Look how much brighter it gets. Because polarization is all about molecules being lined up. And I'm assuming that basically when these leeches stretch out, the molecules that make up their muscle fibers and whatnot all stretch together. They all line up in one. Look at that. Look at that. And so when it stretches out, the polarization goes up. You could do that. You could use that to do science, like bona fide actual science. I don't know what. Study leeches. Oh, this is fabulous. This is so cool. Oh, look at this, guys. Are you kidding me? How about that? No. Dude, I'm so glad we came back for the leeches. We're getting any time we get leeches from now on, we're gonna be looking at them. Oh, look at that! What a beaut. Let's see. I specifically cut out a little piece of cellophane. Yes. Yes. That is what we're going for. This is the correct method of microscopy that we are going for. Look at that. Rich. Unbelievable. Look at, oh wow. Whoa. So I guess like in my head right now, what's kind of like turning away. Oh, this is so cool. What's kind of bumping around in the old noodle basically is I'm looking at these leeches and I'm like, these things are basically just like muscles. They're basically one big muscle. So yeah, the polarization setup that I'm using right now, it's not even really advanced. It's just, so I'm using first of all, I'm using a dark field filter. And then I've just got crossed polarizers. So, you know, kind of your standard polarized light microscope setup. And then on top of the first polarizer, I've got a full wave plate that I've rotated slightly to add some colors. And then on top of that, I've got a piece of cellophane, which sort of shifts the colors that you get. And this is one of my favorite effects here, which is the green and purple. But if I just twiddle the cellophane just a little bit, I can get other results. Oh man, this is so neat. I really, you know, it's funny because I made this slide and I was just like I found leeches and I was like, oh, you know, we've never actually like looked at leeches, so let's just let's do that, you know. And I wasn't really expecting this to be like something I was going to spend a whole ton of time on. But wow, leeches, incredible in polarized light, absolutely incredible. I'm sorry, folks. Some of you might be like, okay, the leeches are cool, but we can move on from the leeches. I understand if you feel that way. But also, You gotta let me cook sometimes. You know? Let me cook. Right now I'm cooking on some polarized light. Hey, it's my little sister. She's in the house. What's up, sis? They do look like spooky ghosts. Man, leeches. Who'd have thought? Who'd have thought? Awesome. Yeah. Wow. Can you guys believe we actually have a lot more cool stuff to look at tonight? Okay. Let's we'll go ahead. We'll leave this slide and I'll get out my next slide here. And I think we'll take off the polarized light. So weird. Okay. Let's put this one over there. We'll put the leeches back in the humidity chamber. We will then put our next specimens in, and we'll go ahead and start off with dark field for these. And I think you guys will enjoy these little guys as well. So, as promised, we have Volvox. And this is a channel first. And actually, I think this is pretty much, I think this is the first time ever, actually, for me, since I started doing hobbyist microscopy, that I've got Volvox. And these things are just so cool. Volvox, a multicellular algae with these specialized little flagella cells and these big internal cells as well. And they just kind of spin and tumble around. It seems like they kind of go through maybe like resting phases or something. I'm not sure. Not sure how it all works. And so this slide here, I deliberately, I was like going through and I was just like getting every single Volvox that I could find. And I just put them all on the slide. Unfortunately, I did get a big bubble here, which is I try to avoid, but look at these things. So the theory with Volvox, and I say theory as in like it's probably is what happened, is that basically you started off and you had single-celled algae that would grow together in colonies, and you can still see those. You can still find algae like that, but over time they evolved to the point where the cells on the outside became specialized, and the cells on the inside became specialized. And so instead of being colonial algae, they are now actual multicellular organisms. Multicellular algae. And they're really cool. You can see them with your naked eye, just barely. They're pretty big. And they're very green. They're just beautifully punchy green. Let's see. We'll do something fun here. If you'll bear with me for a moment. We can put the on. Kind of see him. I don't have a condenser in, but still works pretty decent. Wonderful little Volvox. I'm gonna open up my dark field condenser here. I'm gonna drop my patch top out of it, and I'm gonna install a custom filter that I made. And let's see, you guys can tell the difference. There we go. So this is a Reinberg filter that I threw together just before started. And it's just basically, well, you can actually see, can we actually see the, sometimes you can actually lens in the bubble, you can actually lens the filter directly. But it's basically just a red dot with some very red material. Oh, this is just red in the center and nothing around the edge, and the Volvox contribute all the green that you're seeing. This is cool, actually. These little these look funny. I don't know. These little bubbles here. But so this is actually, I'm working on a little project for the people. So some of you might have played with Reinberg filters before. Some of you maybe have the Journey to the Microcosmos microscope, which comes with them, or I think you can get them part of a package deal. Or you can get them online. But I'm actually working on a concept for a little like starter pack for filters and whatnot. And I know the best filter material to use. It gets you really, really strong, punchy colors. And so I am working on trying to put together maybe some little kits that I can ship off to people. I won't charge too much for them. I might try to make a very small profit on them, just so I can feel like I didn't literally just do nothing with my time. But yeah, so stay tuned for that. I think that's potentially really cool. But I think now we will go ahead and transition back to using my DIC condenser. And I looked at the Volvox before this, but I haven't looked at them in DIC yet. So we will be experiencing this together. And I need to put my good, well, not good, my high magnification turret on. Boom. There we go. And let's bring that up there. Get that going. And there we go. Oops. Need to put in my polarizer. There we go. Huh, interesting. Okay. So here we go. Now we have our Volvox in DIC. You can check them out. Wow, and you can definitely see some more like structure on these little internal cells. You can see like look at that lattice. What's the name of that game? That game where you have like little blobs, you like build little blob structures and stuff. Gosh, it looks very similar to that. It reminds me of that so much. But you can see the little flagella beating away. Okay, let's go to the 20x here. These things are so neat. And you can just see the little flagella eating. This in here. Boom, there. Hello, Sydney. Welcome in. Just looking through these things is so crazy. And let's see, we're up here, we're using our really thin cover glass. We should be able to put the 40x on it. Yeah, sure enough. What we're looking at here when where'd it go? Now we're using the 40x. Wow. Yeah, and look at all these little cells here. And you could imagine that these could be like their own cells. They're not too different than other flagellated algae. Oh, there we go. Running into the slide. Oh, whoa! I think I made a bubble move around there. One that's tumbling. So if I So Gordon, you should be able to see. Make sure you're streaming at 4K. So So we're streaming in 4K, 51 kilobits per second. So you should be able to get a pretty darn good image with this. I notice a bit of compression when I watch on on my TV, but I can usually, I mean, it usually looks pretty darn good, not gonna lie. So just make sure you're at the highest quality settings on YouTube. Wow. Let's go back to the 10x here. That's interesting, huh? How that happens. Oh, you've been watching in 480p. My goodness, my friend. Yeah, I bet it looks a little bit better now. Oh, I'm sorry. You're gonna have to go back and rewatch, I think, because let me tell you, those leeches were looking pretty incredible in 4K. We can go to oh my goodness, a lot of people having that issue. Yeah, make sure you are. This is MicroCinema 4K, and that is not just a buzzword. That is a description of the content quality. Yeah, wow. Oh, I'm so glad we got Volvox. This is tight. Tight. Let's see. Now we're back in dark field here. Yeah, we do the highest quality live stream microscopy in the world here. So if you're ever watching MicroCinema 4K and you're like, hey, this doesn't look very high quality, that's a signal that something's going wrong. Dang. That's so cool. Okay, we will let's move on from the Volvox. And we'll move on to another slide. And I honestly forget which where these came from, but we'll figure it out. I'll remember as soon as I see which organisms are swimming around in here. I think this is from the here's a little critter. I think this is from Quail Hollow Ranch. Oh, look at that Vigulina. So this is another deep well slide. Ostensibly, that means I thought there were critters on here that deserved, that needed a deep well slide. Got a little worm here. We got some diatoms growing on stalks. Those are always kind of interesting. I don't know which diatoms those are offhand. Ah, yeah. Here we go. Okay, it's kind of under some stuff. We have a green stentor. I think we have more of these. Oh, yeah. Yeah, look at that, the Volvox. So yes, confirmed that this is from my the Quail Hollow Ranch station. I got a little ostracod there, a little ostracod action. Can't complain about that. And we have a big old stenostomum. So one of the things that I found with this sample is that it is absolutely full of stentor. There are two species of stentor. There is a kind of colorless species, and then the green one. And I forget which what the name of that one is, but it's a green stentor. What do we got here? Oh, that's another little stenostomum. That's a smaller one. Oh, this stenostomum appears to have eaten a couple of euglenids. Oh, the Volvox are amazing. They're just so like perfect. Perfectly spherical. They kind of remind me of like centric diatoms. That's a little squished little boy there. Yes, here is a stentor. And so this is a stentor with endosymbiotic algae. Stentors are, of course, single-celled ciliates. And this one's looks like it's kind of anchored. There's a little Euplotes. Hey, little Euplotes, what are you doing? It's kind of weird. It's got like a slit going down the whole side of it. Here's our center stretching out a little bit now. You can see the cilia covering it. And these things, yeah, Gordon is asking about, you know, what these things look like in 3D. I just want to say, so I highly recommend, if you are able to, if you're interested in microscopy, you should get a compound microscope, but you should also get a stereoscope. And watching these organisms kind of exist in 3 dimensions in a less restricted environment, like a petri dish, is really, really incredible. You get a lot of insight like into how these things really behave, what they really get up to. Wow, look at this. This is with the 40x lens now. You can see the kind of like striations on the in the body of this thing, in the direction it's stretching out. And here it is. Oh yeah, this is so cool. This is how it's sort of adhering to the glass. It's spread out on the underside of the cover glass right now. It's sticky little bottom here. This is the top, and then I'm focusing down through there. That's so neat. Honestly, like the way that things adhere is a cool little like sub interest of mine, I guess you might call it. Like, because I mean, it really is incredible how strongly some of these critters can stay in one spot. You know, they can fight the currents, and they can definitely fight my pipettes. I'll tell you that much. Something spooked it. Awesome. And we got these big long diatom chains here. Go back to the 10x. Oh, there's a swimming stentor. And something interesting that I noticed when I like collected this sample, I I first poured out some water into the petri dish from the jar, and I kind of like I'll also like use tweezers to add in little bits of debris and whatnot, and just try to get like a nice little microenvironment. Oh yeah, here's the other species of stentor without the algae. And this one is actually cool because it's very see-through. So we can see what it's been munching on, and we can also see its macronucleus. But yeah, one thing I noticed is that like immediately after I made the petri dish and started looking through it, there were tons of stentor swimming around. I mean, they were everywhere. They were just like, I was like, oh my gosh, there's so many stentor. And then later when I went to actually make the slide, I was kind of having trouble finding them. And it's because what will happen is that they'll all find little like nooks and crannies. They'll swim into those nooks and crannies and stick on. And the stentor can kind of hide from you. Wow. Look at this thing. I think, is that a that kind of in the center there? I wonder what that was. It kind of looks like a desmid or something. Oh, this little algae here might be in trouble. Looks like there's like a mucus membrane though it might be globs into. Maybe the stentor likes that. That's a great little stentor. Awesome. Okay. Let's see what else we got. Oh, hey, here's our big old euglena. And it is underneath the worm. Wow. So again, I always interesting just to note, like this worm here is highly multicellular. Highly. And this euglena, it's single-celled. I think this is one of those euglena that doesn't have an external flagella. Rather, it has internal flagella, and it kind of like twists its body around. We can see the nice paramylon grains inside the body. So cool. Is that a flagella? Or no, I think that's just a little filamentous bacteria that it's going by. Yeah. So neat. I love euglenids. They're very chill organisms. At least the green ones are. Some of those white euglenids are pretty kind of predatory and nasty. Well, so the euglena, right, will have they don't have endosymbiotic algae. They have chloroplasts, plastids. Plastids can't exist on their own without being inside the cell. Can't reproduce themselves. That's different than like the stentor, where the endosymbiotic algae is actually its own little thing. Zoochlorella, I think is what they usually call that. Wow, there's that nice trumpet. And these look so cool, honestly. Like in 3D in the stereoscope, like you really get a better idea for like what the stentor is shaped like. It's not all 2D like it's presented here. We'll have to do some live streamed 3D microscopy someday. And here's a rotifer that's kind of pinned. I think this one might be partially squished, unfortunately. Oh, hello, hold on. Perhaps I spoke too soon. Locomoting. But it's kind of got like when the corona slows down like this, usually not a great sign. And these little orbs that are floating around, these little spheres, that's usually indicative of I squished something. Wow, look at that perfect little orb. I think that's a little glob of oil, some kind of lipid, biolipid. I think I actually did maybe squish an ostracod on this slide. No, I'm just going to be buzzing around with the 40X. Oh, yeah, here we go. Yeah. This is where it all came from. This big old ostracod. Wow, look at that. Do a little bit of Brownian jiggling. It's pretty cool. You can see that the larger orbs don't jiggle so much, but the little orbs, they jiggle a lot. Because Brownian motion is affecting them a lot more. Okay, let's go back to the 10X here, and then maybe what we'll do, since we never really seem to regret it, is we'll do a little bit of polarized light. A little bit of polarized light just to see what's out there. Like, we didn't look at the Volvox and polarized light. Didn't look at the stentor. There's a little stentor. Ostracods, we kind of know what they're going to look like. They're going to be extremely bright. This worm. And then the paramylon grains in that euglena, if we can track that euglena down, would also be pretty interesting. There it is. Let's see. Oh yeah, it's right down there. Okay. Go ahead and do it. So we will pop in Zipperizer. We will pop this down. Here. Hello. I told you. Told you. Y'all thought I was playing. Told you those Paramount grains would be showing up. Look at that. There we go. And we can bump this up actually a fair bit. Bring that down. So cool. And then if this thing, I think if it orients itself in more of like a north-south orientation, if it manages to turn itself, I think those paramylon grains should sort of disappear. So that might take a minute. Oh, whoa. Oh, check that out. Hey, so this is the stentor, the clear stentor. And I was talking about that, like I was noting the that thing that I thought was maybe like a Desmond shell or something. I still don't know what it is, but it has a very strong polarization response. And look at these algae inside of it that it's eaten. Those have polarization response. Super cool. But the actual green stentor appears to not have much of anything going on in terms of polarization. Look at that. It's like, so those zoochlorella are just like, there's nothing going on with them in terms of polarized light. Now, ostracod, of course, is just like a big old wave plate with its calcium shells. Wow. Oh, this is a root of duckweed. It's really interesting. Like the cell walls there are showing up bright. There's that worm. It's got a little bit going on, but it's pretty faint. There's our big old stenostomum. Ostracod. Our wow, look at that. That's kind of amazing. Look at the sparkles. It always just like blows me away how crazy these shells are. How optically active, how strongly they react to polarized light. Specifically the ostracot shells. This is crazy with the here. A little bit off. Okay. Whoa. Volvox. You gotta check out the Volvox. Yeah, the Volvox has a nice, gosh, what's the name of that? The Maltese Cross. Usually I take the analyzer out. Sometimes I forget and leave it in. But normally I take it out. I have a intermediate tube on my microscope, which allows me to stick stuff in the optical path, including a polarizer, but also my DIC prisms and whatnot. Whoa. Here's a little water flea. Appears to be mostly expired. Let's turn that back to there. And this is with the full wave plate in. And one of the things that the full wave plate does is it kind of it brightens up everything. Sometimes if you're like not seeing like anything in polarized light, like when you just have cross polarizers, I guess here the stentor is kind of showing up. Let's turn this way down. It can kind of add some extra contrast in. It can, or not even really extra contrast. It can just it can kind of make stuff show up that's more or less invisible in the cross polarizers. Little ostracod with its amazing shell. Is that stenostemum? Okay. Let's go ahead and move on to our next slide, our final slide. I think I'm going to go back to DIC for this one. And this is a slide, so like every slide we looked at tonight so far has actually been a deep well slide. And this is the only one that I have tonight, which is just a flat slide. In this one here, okay, right about there. And here we go. So this is from Glenwood Pond. And something that's really crazy. So I made this slide, I guess, around like 2 p.m. today. Or I made the Petri dish around 2 p.m. today. And wow, check these out. These are Pinularia of some kind. That one's not a Pinularia, that's a different kind. So I made this slide around, or I made the Petri dish around, no, it was around noon, 1 p.m. maybe. And so I made the Petri dish, and then when I came back to check on it around 6 p.m. or so, the entire bottom of the Petri dish was full of these Pinularia diatoms. And they actually have like coated the entire bottom of the Petri dish with this like mucus. Like the entire bottom, they were all just like in this like mucus, and it's crazy. I mean, across the entirety of the Petri dish. So I went through and just pipetted up a whole bunch of these diatoms. I just kept getting more and more and more and just sticking them on. There we go. We got some in girdle view there. We got one in valve view. It's a good little thing here. So we have actually this. So we're using a precision 0.17 cover glass. We should be able to use our 40 quite effectively. There we go. Right. So that's boom. So these are the same species of diatom. On the right, we have a diatom in what's called valve view. And valve view is kind of the one, I don't know if you've looked at diatoms before, it's probably the view that you're gonna like recognize. And then these two diatoms on the left, which look like they've maybe just split, they are in what's called girdle view. And so girdle view is sort of what happens if this diatom here flips, rotates 90 degrees. And so you can see they actually look quite different. They don't have all the striae readily apparent, whatnot. If I go here, it's going to go down a bit there. Yeah. It should go out like that. Yeah. So cool. Wow. Incredible. Annularia. So each of these little, so these ribs are called striae, and each stria, or stria, is composed of tiny little poroids. And those tiny little poroids are like right on the edge of what you can detect optically with a microscope. And so I've had some fun resolving those poroids before. I can do it with my best optics, but only when the frustrals are properly mounted and all that. We won't be able to see them while the diatoms are alive, unfortunately. But there's not just diatoms on this slide. Not that there needs to be anything but diatoms. Let me just make sure my polarizer is, yeah, that's about right. These are just so cool. Ah! I love just having some nice diatoms right under the cover glass, mounted just so. So let's see if we can find some other organisms. Ah, yes. Like this. This is not a diatom. Well, I think it is related. This is a dinoflagellate. I just forget the name of this. It's like, is it Triceratium, or is that the name of the diatom? Yeah, no, that's the name of a diatom. I'm blanking on the name of these guys right now. Let's see if we can find one that's zooming around a little bit. We'll go to 10x. Let's get that going. There we go. And then there is something else on this slide that I'm hoping is still alive. It's been a while since I made the slide. Ooh, is this, oh my gosh, is the slide getting crushed right now? That's maybe not what we're looking for. Let me add a little bit of water. We'll put a little bit of water. I did put Vaseline on the corners. There we go. I hope I didn't crush my special organism that I noticed. And wow! Oh, look at all these diatoms. Ooh, there's a big old Closterium. There's another one. There's a little ciliate. There's another ciliate that is expired. We kind of left all of its cilia there. Hey! It's a paramecium. You can watch the paramecium for a little bit. I want to go to oh, how did I where'd it go? Oh yeah, here it is. Oh man, it's just barely on the edge. Look at this. This is a new one for the channel for sure. Yeah, look at that. This is a crazy looking rotifer. Look at that. I don't know what species this is. I'm gonna try it. I'm gonna give it, so it's right on the edge here. I'm gonna give it, move away here. I'm gonna give it just a little drop of water right near the edge. See if I can let it liberate a little bit. Okay, good, but don't go that way. Go literally any other direction, please. Oh my gosh. So this thing was swimming around. It's very transparent. It looked, I wasn't even sure it was alive at first. It just kind of looked weird, like a little piece of debris or something. But this is actually a super cool rotifer with this huge long spine. And then on the back, just this long point there. And these little horns coming off of it too. And it just kind of was very slowly cruising around in the petri dish. Look at these little algae. I'm gonna give it a little bit more water. That should be okay. I think I shouldn't be, oh, there it goes. Now come back this way, please. Here you go. Yeah. Go back to the 20x here so we can get kind of in the full. Oh, get back here. Dang. There it goes. Kinda. What a weird little creature. Like, it looks very cumbersome to have these spines coming out. But, you know, considering what we've seen recently on this channel and on my Twitch, perhaps it's not so strange that a rotifer would want to be very large and have this kind of big sharp protrusion come off the front that makes it difficult for, let's say, a hungry worm to get purchase on it. Just absolutely radical. Really cool find. Definitely a channel first. We'll have to get this one identified. It's gonna... Oh, here comes some more water rushing in. Let's see what else we got. I'm pretty sure there's more stuff on here. I seem to recall loading this up with a good amount of stuff. Oh, I think that's our rotifer there. Actually, that's like embedded in this this brown stuff. Yeah, that's a rotifer in there. All these little brown algae. Little ciliate there. That's also a dinoflagellate. See, I think there should be more of them. Little Facus. Diatoms. Just grooving and moving. Dang. Hey, there's a little ciliate. Oh, yeah, speedy ciliate. Oh my goodness! Wait, there was something down there too. Well, that's the paramecium. Yeah, we were trying to look at this paramecium earlier. So anytime that you can get organisms, so the thing that I did with this slide that I was really careful about is I made sure that I didn't get any debris on it that was large, larger than my specimens, and then I put a precision 0.17 millimeter cover glass on top. And when you do that, when you're really careful about all of it, you will get much better imaging than you get normally when you're just kind of doing things not too carefully. Get to the Sorry, I'm doing this all one-handed. No. Oh. There we go. This is a very active paramecium as well. You can see the these things have sort of a star or flower-shaped contractile vacuole. You might catch a peek of that when it contracts. The little star shape, those are like canals that are feeding the vacuole. I shouldn't have put all the water on there. It's difficult to track. And here's a little Little algae. Where was that other ciliate at, too? Quickly try to find that other ciliate. Ooh, there's a nice Euglena and Alorica. All these little brown algae. Oh, there's a rotifer. Squished. There's a paramecium. Where did that other little ciliate get off to? That could be anywhere by now, honestly. Oh, there's a nice Cerulella. Where'd you get off to, buddy? And then we can check this thing out. This is a little Euglenid. These things are kind of like kiwis. They have the shape, and they have basically like these it's sort of like a spiny little shell, little crust, and on the inside they're green. And the crust has iron deposits, which makes it kind of golden. We'll go back to 10x. We'll hunt around a little bit more. I'd like to see if I can find another one of those dinoflagellates. I knew there were a few of them on here. And I did see some swimming around, at least when I made the slide. Rotifer. Where'd they get off to? I can't even find the one. There's a ciliate. It's smushed. Oh, there's that ciliate we were looking for. There's some kind of Frontonia? Oh my gosh. You kidding me? Unbelievable. The thing just took off like a shot. It was so well behaved. Oh, there it goes. There it goes. Come on now. Behave yourself. Yeah, I think this is Frontonia. I can see the little mouth. That's characteristic of them. Ooh. And these things, they move kind of like Roombas. Mm-hmm. Oh, there's our Paramecium friend again. Okay, good night, face. Well, this is a little chrysophyte here that got smushed. I can see the little scales with the spines in there. It's interesting. Got some of those on here. I got more. But where is... I just want to see one of these super cool dinoflagellates swimming around. A little Halteria. What's that thing? You not know. Oh, there's one. It got busted open. I think what happened is that just even though I had this in the humidity chamber, it did evaporate a little bit and smush down cover glass on some of these critters that were near the outside. You can see like this diatom here got smashed up. So. But there was that one that looked mostly intact from earlier. Sorry, I'm buzzing all over the place here. Just trying to find it. Okay. This is interesting. This ciliate here looks like it's just chilling. I don't know if it's just smushed or... Yeah, it's got a contractile vacuole going, so it's just kind of dormant. Okay, well, anyway, we will go ahead and do something that I mentioned on the Discord, which is that we will conclude the stream tonight with a little bit of oil immersion. And I thought, like, hey, you know, what better targets than these little diatoms here. And actually, I'm just now realizing I think my immersion oil is on the dining room table, so I gotta go snag that. I'm putting on my 100X right now. Theoretically, if it will actually start to thread in. There we go. Okay. So I'll put this in and then give me 2 seconds to go get my immersion oil. Okay. Let's see. Let's find a good spot I mean, probably where all these diatoms are all clustered together, not on the outside there. Yeah, I guess we'll go right here and then we can kind of check in on that ciliate too. So let's go ahead, we'll get the 40x going. Make sure we're down focused with that. All right, we'll set my stop lever there. And we'll take this down. Put a drop of oil on the slide. Make sure that is the 100x right there. And we will rack this up. Let's see. Oh, I see it there. Actually, all right here. Give me a sec. Go. Okay. I'm sorry for that dot on the screen. I should have known it was high magnification. That would be pretty apparent. Okay. Oh yeah, and then there we go. Yeah. Down like that. And we can see a lot of stuff going on inside of the diatom there. A lot of stuff like swarming and roiling around. And then we can see it looks like it's got bacteria on the exterior. Let's see if we can't a little bit more. Oh, hey, check it out. Here's this, whoa. Here's that ciliate. Hey Eric, how you doing? You know what, let's while we're here, let me go ahead. I don't know how much of a difference this is gonna make, but yeah, we can just do it because we want to do it. I'm gonna oil my condenser as well. And we'll just see if that changes anything. It may not. Go right about there. There we go. Did it change anything? Who knows? So right now we are using the 100x S-Plan Apo. you might be wondering, why am I using my 100x when I have a perfectly good 60x with the same numerical aperture? We'll get to that. But for now, we can enjoy these big old diatoms. Ooh, here's a nice girdle view of the pinnularia. That's interesting. It's got these little like perforations running down the side. And they all have just a little bit of like bacterial. These look, yeah, they're actually cocci bacteria. Interesting. There's that. There's that other interesting little species. Well, so I'm using the DIC condenser, Eric, and the DIC condenser is an A-plane app. But theoretically, the DIC prism is set for an NA of 1.25. So I don't know. Theoretically, like, it could get a little better than this if I had like the exact right prism to match. But what I actually wanted to do tonight was not just do DIC, but do a little bit of high magnification dark field. Just because I haven't done that in a while. Like I've used my oil dark field condenser a lot to do diatom imaging with like hyperlight techniques, but it's been a while since I just did a good old-fashioned dark field. Okay, this thing is definitely not. There we go. That's not quite centered. There we go. Now we just need to get this thing into position. This can always be a little tricky here. Let's see, let's lower it down. Let's see where. Let's see there. I don't understand why I'm getting. Oh, I should take this out for one. So right now we're getting kind of like a oblique light on this, but I don't know why I'm getting that, that dark spot. Could be. Like I should be. What I really should be getting is just a nice. Give me 1 second here. Okay, let's see. I thought maybe I had fixed it, and then it did not. The other thing could be happening, yeah, I could just have oil kind of not distributed properly. This is an Amscope product that I'm attempting to use here, so definitely can be prone to issues. What's going on? I wonder if that could be an issue, actually. Oh, that's crazy. Sorry, folks, for the technical difficulties. I guess I should have practiced this before. I don't normally have issues with this, but let's see. Okay, hold on just one second. Okay, so I'm gonna go ahead and kind of reset stuff here. Yeah, I think I actually know what might be happening. Okay, I'm just gonna carefully that out. Okay, so I think I might actually have to take my stage off that I'm using right here and use a different one. I should do this properly, just take this off. Yeah, sorry for the extended stoppage here. But that's the end of the night. We'll deal with it. Okay, yeah, pop that in there. Oh yeah, this is my... Alright. There we go. I think I got it now. I think we got it. Okay, but I might have to... let's see. There's a diatom, kind of. Now I just gotta get my... There it is. Ah, yeah, here we go. All right. All right, hold on now. Okay, and then raise that up. Okay. And now I think we should be in circular oblique light. Again, sorry for the extended interruption. Oh my gosh, this stage is so touchy compared to my other one. Wow. I don't actually know that I prefer that. Okay, so for anyone who's still sticking with me here, right now I've got a 1.4 numerical aperture lens in and a dark field condenser that does not, it won't project a dark field to that numerical aperture. But the 100X has a built-in iris. And so if I turn that iris down, and I can get 100X dark field. It's kind of messy. But also pretty cool. Interesting, the stuff that's out of focus is just like really, let's see if I, oops, that's the wrong way. Oh, can I, yeah, that's maybe, yeah. Right there, I think. So now I just gotta find something good to look at here. Yeah, so the 100X has the 100X S-Plan Apo has a built-in iris that allows you to basically turn down the numerical aperture of the lens. And so you can kind of turn it down if you have like a really nice dark field condenser. This allows you to like get to the numerical aperture, like the best possible numerical aperture that you could get in dark field for the condenser that you have. It would be nice if we could stumble onto one of those ciliates again. I kind of lost it when I went away. Here you can see all these little doodads. It's right under the cover glass. But yeah, this is just a cool thing that you can do. If you get one of these, and these lenses, it's pretty common to, oh, whoa, look at that. This diatom just ruptured. I probably should put a little bit more water on the slide. I think it's probably getting, it probably got cracked. But yeah, you can get these objectives. I think most of the major microscope manufacturers made 100X objectives with irises built in. Howdy, Planktonic Nomad, welcome in. And oh, here comes the water. Okay, maybe we can go back now. And you can see like anything that's like super thick will kind of show up. Oh. A little golden algae. Dang, I really want to find one of those ciliates. See what that looks like. And if I open up the iris all the way, I won't. Let's see. Let's bring this down. I think I maybe decentered this a little bit. I should get a nice, when it's properly set, I should get a nice, fairly even illumination. I should get circular oblique illumination. Let me see, I might need to re-oil a little bit. There we go. That's pretty close. So yeah, this is what you would generally call circular oblique illumination. So you're not getting a dark field, but you are like illuminating from kind of a circular structure, the way that you've got the light. And so this can kind of give you interesting results sometimes. It's almost like a budget phase contrast or something. Where are all my diatoms at? And what we can do also is mix this with polarized light, cross-polarized light. Okay, polarizer in, and put our initial polarizer down. We might have to turn the exposure up a lot. Yeah. I'm not getting the cleanest results here. Sometimes this can look really good. But I'll say. And now it's just kind of looking a little fuzzy, a little not it. Yeah, I have to turn my ISO up to like crazy amounts to get this to work, unfortunately. It's interesting though, I've gotten similar results before I don't know. Yeah, this is 100x dark field. They are tempting to do. I thought it would look a little better. I don't know. I guess these diatoms themselves, like the problem is that here I'm focused up at the top, and I'm getting all this bloom around the diatoms from the autofocus stuff. That kind of reduces the image quality. Well, you can still see like here, you know, it's interesting because you can see those little tiny perforations here in this diatom frustule. I wonder how big those are, how far apart they are. Those are pretty fine features. And so that's something that might not show up if you use just bright field microscopy. These little duders capture the light. I think also this condenser, this AMScope condenser, just has like poor optical performance. So you get these like weird chromatic effects and whatnot. I think that's potentially solved with a better quality dark field condenser, which I have a few of. I just don't have any that fit my my BH2 easily. So anyway. That one looks better for whatever reason, just kind of the way it's oriented or whatever. It's a nice view of the striae. Yeah, somewhere in there, somewhere in those little ribs are tiny little poroids, but I think you can only really ever see them when the frustule is mounted in a nice high refractive index mount and prepared very nicely and all that. Maybe if I found a species with like unusually large poroids, maybe I can see that. I feel like I can just barely make out like at least some modulation. I don't know, maybe that's just this kind of graininess in the background. Should be like right about there is where I should be seeing them. Maybe right there. such weird effects when you do these like super high numerical aperture dark field kinds of things. Yo, actually, right there. I think I'm seeing at least some, like sometimes the poroids have kind of like little interruptions, little defects. I really do feel like I'm maybe capturing some of that stuff in this, which is cool. I'm getting at least some imaging of that structure. This one's missing a stria. Here on the edge. Spin the polarizer again. Oh, it's maximally. Okay. Okay. Well, I'm sorry. I've just kind of devolved to experimenting in front of all of you right now. So, I think we'll go ahead and call it a night here. If you just joined, you missed some really cool stuff. We had some incredible leeches. Seriously, like leeches and polarized light is like one of my new favorite things in microscopy. So definitely go check that out. And let's see, we also had Volvox just looking amazing, and yeah, probably some other stuff too. A lot of fun stuff today. Back to the this is how I should have done it. Yeah, so I could have gotten that lined up. So yeah, anyway, I will try to put some chapter titles in and whatnot, and so you guys can go back and find that stuff. This one. There's one of those dinoflagellates I was looking for. Here it is. Okay. Yeah. Have a good night, everybody, and yeah, I'll see you next weekend. So, cheers.